Session 7, Planning for Logistics. This session is divided between a formal lecture on logistics planning followed by tutorial exercises. It is in your best interest to try out these tutorial exercises. You will be expected to work in groups and complete tutorial tasks during the following week's session. The lecture schedule is as follows. We'll talk about logistics design and strategy, logistics network planning, product life cycle, packaging, and unit loads. So what are the factors influencing logistics systems? These are competitive pressure, product proliferation and shorter product life cycles, pressures for improved performance and inventory reduction, changes in players' role and distribution channels, the need to redesign and improve efficiency, pressures to develop supply chain vision and cooperation, improved communications and information technology, changing material handling and transport technologies, regulatory changes, increasing customer service requirements. All of these influence logistics systems planning. Pressures are brought on logistics systems to continually look at possibilities of changing in order to align these to the changing business environment. Changes and improvement in ICT, such as ERP, EPOS, EDI, use of the internet and mobile apps for real-time data to improve information and product flows in the supply chain. Regulatory changes, such as EU laws, growth in the importance of environmental legislation and labor laws, increasing customer service requirements, often seen as value-added and providing a competitive edge in order to differentiate from companies offering similar services. Shortened product life cycles, which is actually the trend today, and the need to improve financial performance because of this. Introduction of new players and new roles within channels of distribution, including the growth of 3PL providers offering global and pan-European operations and supply chain partnerships. Need to reduce inventory and associated costs via depot rationalization and adoption of just-in-time concepts in logistics. All too frequently, the logistics function is outsourced, therefore not fully integrated in the supply chain and corporate strategic plan. Organizations should include logistics operations in their corporate strategic plan. The external environmental factors and internal factors of an organization would generally influence the development of the corporate strategy of an organization. This would then be used to drive the competitive strategy, which in turn influences the functional strategic plans. Generally, marketing, finance, and production are the main functions that are considered in a lot of organizations. However, logistics also is one of the key functions that needs to be considered. External environment in logistics. A brewery's core product is beer, and it's packaged in a number of ways, including barrels, kegs, cans, and bottles. This has implications for logistics and distribution. Distribution channels traditionally involve clubs, pubs, bars. Transportation is an important consideration to ensure that product is delivered into such outlets. Other distribution environments include food and wine outlets, often referred to as leisure or lifestyle experiences, such as restaurants, for example. Home consumption, where beer is purchased at off licenses, corner shops and supermarkets. Packaging, storage and distribution is an important consideration in logistics. In logistics, it is important to provide a good service at the lowest possible cost. This means that logistics providers must differentiate themselves from their competitors. Service-oriented structures involve service-enhancing approaches such as next-day delivery, tracking systems, and information support systems. But however, it's best to keep in mind that these will increase costs. So what are the cost-oriented approaches? Cost-oriented approaches in logistics will reduce costs, particularly on full load deliveries. However, it's best to keep in mind that minimum order sizes over 48 or 72-hour delivery will limit service possibilities. Organizations should decide whether they need to pursue a service leader approach or a cost leader approach in logistics. If it is a service leader approach, these organizations can leverage on the following opportunities: tailored service to the customer, distribution channel strategies, reliability, responsiveness, information, and flexibility. If they would like to follow cost leadership, then they should leverage on capacity utilization, asset turn, low inventory, and low wastage. However, no organization can operate at either of these extremes. They generally have to follow a middle path to be efficient. This slide shows the framework for logistics network design. It starts with the corporate strategy, which will drive its competitive strategy, and in turn, the logistics strategy of the organization. So in a logistics strategy, you will have the logistics process design, logistics network design, logistics information systems design, and logistics organizational structure. Traditionally, logistics planning and design have evolved around the structure of the logistics network, such as number of depots, number of facilities, and location. There are other considerations as well in logistics design in terms of logistics processes, information systems, and logistics organizational structure. Logistics process design ensures that business functions are aligned across company operations as an integral part of the supply chain. Logistics design should include order fulfillment and should provide seamless operations across the different functional areas of the supply chain, including sales, warehousing, and stock control. Other fulfillment processes include product information, returns, and spare part provision. Logistics companies also need to take account of customer service as well as product requirements. So what is the most appropriate logistics organizational structure? This is often seen in isolation from other supply chain attributes. Again, it is important that logistics is integrated with the supply chain. This diagram shows the 4 stages in supply chain integration. Stage 1 is the baseline. Stage 2, the functional integration. Stage 3, the internal integration. And stage 4, external integration. Physical distribution channel types and structures. There are several alternative physical channels of distribution that can be used, and a combination of these may be incorporated within a channel structure. Manufacturer direct to retail store. As a general rule, this channel is only used when full vehicle loads are being delivered. Thus, it is quite unusual in today's logistics environment. Manufacturer via manufacturer's distribution operation to retail store. This type of channel is still commonly used by the brewing industry. Manufacturer via retailer distribution center to retail store. A direct result of the growth of the large multiple retail organizations that are now a feature of the high street and of the large retail parks. Manufacturer to wholesaler to retail shop. They were generally begun on the basis of securing a price advantage by buying in bulk from manufacturers or suppliers. Manufacturer to cash and carry wholesaler to retail shop. The increase in cash and carry facilities has a reason, as many suppliers will not deliver direct to small shops because the order quantities are very small. Manufacturer via third-party distribution service to retail store, mainly due to the extensive rise in distribution costs and the constantly changing and more restrictive distribution legislation that has occurred. Manufacturer via small parcels carrier to retail shops. Small parcels companies specializing particularly in next day delivery. Manufacturer via broker to retail store. A broker is similar to a wholesaler in that it acts as intermediary between manufacturer and retailer. There are different types of distribution channel for these flows, which are sometimes referred to as business to consumer or B2C. Mail order. Goods are ordered by catalog and delivered to the home by post or parcels carrier. Factory direct to home, specially made and do not need to be stocked in a warehouse to provide a particular level of service to the customer. Internet and shopping from home as a mail order. Factory to factory, business to business. This may cover raw materials, components, part assembled products, etc. An individual company may have many different products and many different types of customer. Such a company will therefore use a number of different channels within its distribution operation. In this example, you can see the diagram. There are two channels, the physical channel as well as the trading channel. Channel objectives will necessarily differ from one company to another, but it is possible to define a number of general points that are likely to be relevant. Channel selection will depend on a number of points. To make a product readily available to the market consumers at which it is aimed. To enhance the prospect of sales being made. To achieve cooperation with regard to any relevant distribution factors. To achieve a given level of service. To minimize logistics and total costs. To receive fast and accurate feedback and information. If a market is very large, one that is widely spread from a geographic point of view, then it is usual to use long channels. Where a market has only a few buyers in a limited geographical area, then short channels are used. Product characteristics. Product characteristics will influence the selection of appropriate channels. High value items are more likely to be sold direct via a short channel because the high gross profit margins can more easily cover the higher sales and distribution costs. Complex products often require direct selling because any intermediary may not be able to explain how the product works to potential customers. New products are often distributed via a third-party channel because final demand is unknown, and supply channels need to be very flexible to respond to both high and low demand levels. Time-sensitive products need a fast or short channel for shelf life reasons in the case of food products. Products with a handling constraint may require a specialist physical distribution channel. Example, frozen food. So product characteristics refer to the physical properties of the product. Short shelf life, fast moving, highly perishable, frozen, ambient, etc. Such characteristics will determine logistics systems design and planning. There are four main categories to this. Number 1, volume to weight ratio. Number 2, value to weight ratio. Number 3, substitutability. Number 4, high risk product. Volume to weight ratio. Volume to weight ratio is to do with efficient distribution. Low ratio of volume to weight, such as sheet steel for example, means that weight constraints capacity for road transport vehicles will be offset by handling costs in storage. On the other hand, high volume of weight ratio, example paper tissues, they use up space and are costly to transport and store because their logistics costs are on a weight rather than volume basis. In Europe, drawbar trailers are used to increase vehicle capacity, thereby reducing transport costs of moving high volume and low weight products. Distribution costs for high volume as opposed to high weight are higher. Total cost movement and storage increase as the volume to weight ratio increases. Value to weight ratio. The value of the product is important in logistics and distribution. High value products are more likely to absorb distribution costs. Low value products need to include inexpensive distribution systems as costs present too high a proportion of overall product costs and could make the product commercially non-viable. Low value to weight ratio include products such as sand and ores, etc. incur high transport costs compared with high value to weight products. Storage of low value to weight ratio products tend to be low compared with costs of high value products because of the amount of capital tied up with inventory. There is a trade-off effect as value to weight ratio increases. Substitutability. Substitutability is the extent with which one product can be substituted for another. Customers accept different brands or types of goods. For example, customers may accept a different brand of food as an alternative if first choice is not available. In distribution, this can be accommodated through high stock levels or high performance of transport modes. Both options incur high costs. High stock levels reduce risk of stockouts but will increase cost of storage and inventory. Provision of improved, faster and frequent transport will reduce acquisition, time, length of stockout but increases service and transport costs. High risk products. High risk products include fragile, hazardous and dangerous goods. This is where goods need to be isolated from one another in storage and transportation. This also increases overall distribution and transport costs. High risk goods require special packaging and limited load size, special labeling. Regulations for movement of hazardous goods may require specific modes of transport. Fragile goods. Fragile products also require special packaging due to handling and transport. Specialist distribution service providers will be used. Time constraint products. Foods are time constraint products and therefore have a limited shelf life. Both EU and UK food safety regulations place requirements on sellers to have best before date and or use by date. In logistics, this means that goods are fast moving and have frequent deliveries, particularly early morning time frames. However, it is not just food. Clothes, fashion apparel require fast turnover in stores. Agrochemicals such as fertilizers and pesticides have fixed time periods for usage. Seasonal goods such as Christmas cards, Easter eggs are all time constrained. All time constrained goods have implications for warehousing and distribution. High value goods. These include goods such as cigarettes, DVDs, CDs, and pharmaceutical, for example. In particular, pharmaceuticals are attractive products and require secure means of distribution. Product characteristics determine mode of transport, conditions required in storage and transportation, thereby influencing demands on logistics provision. Understanding the different stages in a product life cycle is important for effective logistics planning. Development introduction stage. This stage, the product developed to meet new demand. Logistics operations respond to stock availability and quick replenishment. Logistics should react to fluctuations in demand, which places need for accurate and robust information, and data flows between company buyers and sellers. Centralized stocking base used for fast mode transport. The growth stage. Here sales are more predictable. This requires efficient transport and distribution systems for cost reduction. There may be trade-offs between cost and distribution. Then we come to the maturity stage. Substitutes and new products cause price increases and competition from other sources. So effective logistics operations are more critical if maintaining market share, particularly for key customers. The final stage is the decline stage, where product starts to decline. Logistics need to support existing business, but at the minimum risk and cost. Logistics should take account of PLC and become flexible and dynamic to respond to customer requirements. Packaging. The physical requirements of the product in terms of packaging and handling, both in storage and distribution. The packaging of a product is determined by product promotion and placement. Packaging should be easy to handle, convenient to store, and makes the best use of space. Cubic rather than cylindrical packaging is more efficient. Unit loads. The use of a unit load was born out of the need to devise efficient handling. Unit load enables products to be grouped together. Wooden pallets and large ISO shipping containers enable products to be grouped together. You need to try this tutorial. We can discuss this in a classroom setting.